This is for lesson 14. This is our first part on elimination. So the first thing we're going to do is look at like terms. We're going to rewrite each expression by combining the terms. So we have 11s minus 2s. They both have the same variable, so we can combine these two terms. So we're going to have equals 9s. So we take the 11 and subtract the 2 and leave the s. For number 2, we have 5t plus 3z minus 2t. What do you think we're going to get from that? Can I combine any of these terms? All right, so we can combine our two t terms. We have a 5 minus 2, and we leave the 3z. So 5 minus 2 is 3. We leave our t attached to it, and then we add 3z. All right, now we have 23s minus the quantity of 13t plus 7t. Can I combine any of these terms? We can combine the 13 and the 7 because they both have t's. What is 13 plus 7? 20. We leave our t attached. We keep the subtraction sign from the front. And then we just drop down our 23s because we didn't combine that with anything. All right, what do we do with this one? We have 7t plus 18r plus the quantity of 2r minus 5t. Does this plus sign right here change anything about the parentheses? No, so I can just get rid of my parentheses here because it leaves them positive and negative. The 2r stays positive and the 5t stays negative. So I have 7t minus 5t. What is that? 2t. Then I have 18r plus 2r. What is that? What's 18 plus 2? 20. So we put our r there. All right, number 5. We have negative x plus 6r minus the quantity of 7x plus 2r. Does my negative outside my parentheses change anything about what is in my parentheses? It does. My negative has to be distributed to every term in the parentheses. It's like if I had a number outside the parentheses. Sorry, I'm just going to erase that little bit right there. So we're going to have negative 4x plus 6r minus 7x minus 2r. Then we're going to combine our terms that have the same variable. So I have negative 4x and negative 7x. 7x, not 6. I was going to say 6. When I combine those two, we have a negative 4 and a negative 7, so we add the numbers and keep the negative sign. So we get a negative 11x. Then we have 6r minus 2r. So 6 minus 2 is 4. It's positive, and we keep our r attached. All right, 14.1, notice and wonder. We have hanger diagrams. If you remember these from last semester, I feel like we had at least one lesson that had these diagrams in it. All right, so what we want to do with these is we want to look at it and think of it like it's a balance. Like, do you know how in science, you know those balances that where you can put stuff on one side and you have to like weigh it out on the other? It's kind of like a scale, but specifically it's a balance because it's kind of like a teeter-totter. Did you guys play on those when you were kids? Where you like you went back and forth? It's kind of like that, but like trying to make it even to where like you're balancing, where you're both at the same height, okay? So what we did with this is we looked at these and said 2 circles equals 1 square.
When it's like that, does that mean it's balanced?
Yes. Okay. Over here we have 1 circle and 1 triangle. Equals a pentagon. Okay. And these are a little bit bigger than I anticipated them being, so the next one is on the next page. So you're going to have to turn over to the next page. What do we see here? Does any of this look familiar from what we saw on the last page?
Yeah.
Okay, so we had 2 circles equals what?
1 square.
1 square. And 1 circle and 1 triangle equals 1 pentagon. Okay, so if we add those together, it's still going to be equal, right? Okay, so let's go on to adding equations. We have Diego is solving this system of equations. We have 4x plus 3y equals 10 and negative 4x plus 5y equals 6. Here is his work. So what did Diego do between the 2 equations right here? What did he do? What's the difference between here and here? And really I want to look at from here down to here. What did he do right here? How did he combine the terms? This sign right here. This is the major difference between this right here and this right here. We added the 2 equations. So added the equations. Okay, and he got 0 plus 8y equals 16. Then what did he do between here and here? So let's do it like that.
Where did the 0 come from?
So 4x plus negative 4x is
0.
0. There's the 0. What did he do from this equation to this equation? Divided by 8. Okay. What did he do over here? What does this equation tell me? Actually, I'm going to zoom out just a little bit. Where did that equation come from?
I'm trying to figure out what X is, that part.
But where did the equation come from first? What equation is this? So this is going to be our top equation. That's where it came from. And they plugged in, or Diego plugged in, the value we got for y. Okay? That's where that 2 came from. Then from here, he solved 3. So let's see here. The first step was substitute in the value solved for already. In this case, it was y equals 2. And he used one of the original equations. Okay, doesn't matter which one. He just chose to do the top one, so we're going to look at that. Then he solved from here to here. He multiplied the 3 and the 2. So that's where the 6 came from. Then what did he do from, let's change to a green. What did he do from here to here? How did he get from 4x plus 6 equals 10 to 4x equals 4? Minus the 6. Or subtract 6. And I know that looks kind of funky. It'll be okay. And lastly, we have, let's do the pink. What do we do from 4x equals 4 to x equals 1? How did we get to x equals 1? How do we get rid of those 4s? Divide. We divide by 4. All right, so we're supposed to make sense of Diego's work and discuss with a partner. We kind of already went through the work, but I want you to write down here that what he did to solve the system. He added the equations together. Which eliminated a variable. I'm going to put in parentheses the x. Okay. So to eliminate a variable, we get rid of a variable by making it go to 0. So it has to be the same terms. We have 4x minus 4x, so we get 0. Okay? If I had 4x and 4x, what do you think I would do to get rid of that? Instead of adding, I would subtract. Okay? Is the pair of x and y values that Diego found actually a solution to the system, and how do you know? So what we could do is we could plug it into the equations. We could say, so the final solution he got was 1, 2. We could plug it into both equations, and I'll do the top equation in blue. So we'll have 4 times 1 plus 3 times 2 equals 10. What's 4 times 1? 4. What is 3 times 2?
6.
What is 4 plus 6?
10.
Does 10 equal 10?
Yes.
Yes. All right. Do the same thing for the other equation. We have negative 4 times 1 plus 5 times 2 equals 10. What is negative 4 times 1? Negative 4. What is 5 times 2? Oh, I put 10. That was supposed to be 6. Sorry. I don't know why I did that. 5 times 2 is 10. Negative 4 plus 10. What is that?
6.
6. Does 6 equal 6? Yeah. So it is a solution to the system. And how do we know? Because it works for both equations. So it is a solution. All right, go to the next page when you're ready. All right, so does Diego's method work for solving these systems? So if I just added these two equations together, what would I get? What is 2x plus x? So I'm going to point here. So we're going to do 2x, and we're going to add using this sign, positive x. What does that equal? 3x. What is y, whoops, pointing, y plus negative y? What does that equal?
Where'd you get the plus sign from?
So we're adding, we're using the method that he used right here. Okay, so we're just going to add the equations.
0.
It's 0. So I can put plus 0 if I want to, or I can just leave it out. I like to do, you know how I cross things out when we are moving something from one side of an equation to the other side? You know how I normally do that? I like to do that here and just mark it out. As long as you can see that it's gone, I'm fine with that. If you need to see that it is plus 0 and you want to write that down every single time, I'm totally okay with that too. Then lastly, we're going to do 4 plus 11. What is that? 15. So do you think that's going to work for this equation? Is this method going to work for this system? Did we eliminate a variable? Yeah. So yes. Addition works for this system because it, oops, that looked funky. It eliminated a variable. Specifically here, it eliminated the y. Okay. Gonna do the same process here on the second one. We're just going to add our two equations. What is 8x plus 8x?
16x.
Okay. What is 11y plus y?
12y.
12y. And 37 plus 7 is?
44. 43.
No, you're right, 44. Okay. Does this work? Does addition work for this system?
No.
No. So because it did not eliminate a variable. Would subtraction work here? What do you guys think? Why would it work?
Because 8x minus 8x is 0.
Right. 8x minus 8x is 0. What's 11y minus y?
10y.
Okay. And what is 37 minus 7?
30.
30. I'm going to say, but subtraction would eliminate a variable. All right, so as I said, we have system A, that was Diego's. He used the sum and he solved it. So for system B, we already did part of it up here. We know that we're going to add it and get 3x equals 15. What do I do to solve for x now? Divide by what?
3.
Okay, so x equals what?
5.
Okay, then what do I do? What did Diego do next once he found a variable? He used substitution. So we take our x equals 5 and we plug it into one of our original equations. Do we want to use the top equation or the bottom equation? The top one? So we will have, what will we get when we plug in the 5 into the top equation? So 2 times 5 plus y equals 4. So the only thing that changes is our x value. Our x value becomes the value that we found before. So now how do I solve for the y? Times 2 and 5. What is 2 times 5? 10. Okay, now what do I do? Minus 10. What does y equal? -6. And I want my final answer to be a coordinate because we have x and y. So we're going to put 5, -6. So we already saw system C when we were up here and we subtracted them and got the 8x's to cancel out or to be eliminated. And we got 10y equals 30. Now how do I finish solving for y? What do I do now? Divide by 10. So we get y equals what? 3. Now what do I do? What do I do now that I have a variable? Plug it back into the equation. Which equation? Does it matter?
No.
It doesn't. It can go into either one. So do we want to use the top or the bottom? top. So we're going to have 8x plus 11 times 3 equals 37. What is 11 times 3? 33. What do I do now to solve for x? We're going to subtract 33 from both sides and get 8x equals 4. Now what do I do? Need to get the x by itself. To do that, we need to get rid of the 8 by dividing. So we're going to get x equals 4/8, which equals 1/2. So my final solution is going to be 1/2, do that, comma, 3. All right, make sure you do your practice problems, and I'll let you know which one counts at the end of the week.